Good morning. Let us start our lecture today. Last time we was trying to study second order differential equation with constant coefficient. The general method is to look for a characteristic equation of this equation. So the characteristic equation will be of the form AR squared plus BR plus C is equal to 0. Right? So for this characteristic equation, there are three cases. In the previous class, we learned two cases. Case number one. So in this setting, we have the delta to be B squared minus 4AC. All right, so case number one, if delta is strictly positive, we have two roots, right? The first root will be minus b plus square root of delta divided by 2a. And the second one will be minus b minus square root of delta divided by 2a. All right? So if delta is strictly positive, you have two roots, and both of the two roots are real. The first one is minus b plus square root of delta divided by 2a, and the second one is minus b minus the square root of delta dividing by 2a. Then in this case, you have the general solution will be xt is c1 exponential of r1t plus c2 exponential of r2t. So c1 and c2 are constant. All right. In this case, you have two roots. The two roots are real. So you have two solutions: exponential of r1t and exponential of r2t. To have a general solution, you're gonna combine them. So you put two constants, c1, c2, and the general solution will be c1 exponential of r1t plus c2 exponential of r2t. Right? It's clear? Now, case number two. Case number two, the delta is smaller than 0. All right? So then you also have two roots. R1 will be minus b over 2a plus I, the square root minus delta over 2a. All right, and R2 will be minus b over 2a minus the square root of delta dividing by 2a. All right. In this case, you also have two roots, but you're gonna have the imaginary part. So the two roots are complex roots. So in this case, the two solutions will not be exponential anymore. They're going to be exponential multiplying with the cosinus function. All right. So you're going to have the general solution of the form xt is c1 exponential of minus b over 2at cosinus of square minus delta over 2a plus c2 exponential of minus 2b b over 2a sinus of the square root minus delta over 2a. All right? It's good? So in this case, you see that here you have the real part and the imaginary part. The real part of the solution will go to the exponential. All right? And the imaginary part will go to the cosinus and sinus. All right? So it's only go here. In this case, the real part is minus b over 2a. So now you have exponential of minus b over 2at, and the cosinus have minus the square root of minus delta over 2a. This is why here you have cosinus, right? So case number three. Delta is 0. So what happens when delta is 0? Yes?
Do you have a single solution?
You have a double solution. So what is the double solution?
Is it when R is negative B over 2A?
Yes. Can you stand at the back of the paper, please? Right, so in this case, you want to replace delta here. Delta is 0, meaning that R1 and R2, they're both minus B over 2A, right? So in this case, we have a double root. So R will be minus B over 2A. All right? This is easy to see because you replace delta to be 0 here. When you replace delta to be 0 here, this is going to be 0. What you have from R1 is minus B over 2A. And when you replace 0 here, you also have minus B over 2A. Basically, when delta is 0, R1 and R2, they are equal. Because they are equal, then I said that this is the double root. So what is the solution in this case? Yes?
X is equal to a constant times e to the negative b over 2a times
Right.
t.
Can you say at the back of the paper, please? So the solution will be, the first solution will always be e to rt, which is e to power minus b over 2a. This is the first solution. All right? All right, so the first solution is always the same. You're going to apply this formula, right? You apply this formula and you still have C1 e to RT and C2 e to RT, but they are equal, right? So in this case, you have one solution like this. And the second one will be, I'm going to give you the formula, but we're going to learn how we can get this formula in the next lecture, because it is going to need some very complicated method. Right, so the second solution, the second solution will be T e to RT. So the general solution will be all right. XD is C1 e to R to the minus B over 2AT. So this is E minus B over 2AT. So you're going to have C to B minus 2AT. All right? I'll explain again. In the case that delta is 0, when delta is 0, you replace it here. You will see that R1 and R2, they're both minus B over 2A. Right? Because here the delta disappears, and here the delta is also disappear. In this case, I call it a double root, right? And the double root has the formula R is minus B over 2A. Basically, this is what you get when you replace delta to be 0 over there. So the first solution is the same. Exponential of t, which is exponential minus b over 2at. All right? The second solution, I give you the formula. This is t e to rt. Why do we get this? We're going to learn this in a couple of, probably this lecture or next lecture. All right? So the general solution will be the linear combination of the two solutions here. So you have C1 exponential of minus b over 2at plus C2 t e to power minus b over 2at. It's clear? So this is the table that you have to memorize because it's going to be in the test, of course. So you have to memorize the three cases. So I think this is not so difficult to memorize, because the first thing you have to memorize is this characteristic equation. You have to know how to write out the characteristic equation. This is standard. Right? First step is always to write out the characteristic equation. All right? You have this equation, so you write down like this. And this is not difficult. Now you consider the delta function. The delta is b squared minus 4ac. All right? the delta, if the delta is strictly positive, this is a quadratic form, so you have two real roots, R1 and R2. So you have two real roots, and then you just put exponential. All right? In the case of delta is negative, the two roots are not real root, they are complex. Right? In this case, you have minus b over 2a plus I square root minus delta over 2a, and here you have minus b over 2a minus I square root minus delta over 2a. You can apply the same idea, the same method. Exponential of R1 and exponential of R2 is going to give you the same answer. But when you apply the exponential, this is because of the Euler formula, so the imaginary part will turn into a cosinus and sinus. So what you need to remember is that here, for the real part is going to be the same. So you have exponential, so the real part here is going to be exponential. The imaginary part here will become the cosinus, right? For the last case, you have only one solution, or you have a double solution, right? Because when you replace delta to be 0 here, R1 and R2, they're both minus b over 2a. So the first solution is, of course, exponential. And for the second solution, you just have to remember to multiply t with the first solution, right? So why do we have to multiply t? I'm going to explain it later. Questions? So for the last case, you have one solution. So the first x1 is always exponential. The second one is obtained by multiplying t with the first one. Right? Right, so let us try to do some exercises. So this is a table that you have to learn, because in an exam you're going to be asked to solve those equations, and if you don't remember the formula, then this is going to be difficult. All right, so let us try to solve this equation. X second plus 2x prime plus x is 0. Solution. So what is the characteristic equation? Yes?
R squared plus 2r plus 1.
Yes, can you say at the back of the paper, please? So you have r squared plus 2r plus 1 is 0, right? So this is the characteristic equation, because the constant here is 1, so you project it to r squared. The constant here is 2, so you project it to r, and the constant here is 1, so you project it to 1, right? So the characteristic equation is r squared plus 2r plus 1. What is the delta function in this case? Yes?
It's 4 minus 4 times 1, which is 0.
Can you say at the back of the paper, please? So in this case, the delta function is 2 squared minus 4 times 1, right? So you're going to take this, and you take the square. And you multiply this and this, you multiply with 4. All right? In this case, you're going to take the middle, and you take the square of the middle. And then you multiply the first and the last with 4, and you take a difference. In this case, the delta is 0. So what is the double root? Yes?
Just r equals negative 2 over 2, so it's just -1.
Yes, can you sign at the back of the paper, please? So in this case, the double root will be minus 1, right? Even without using the formula, can I say that the double root is minus 1? Why?
If we factor the first function, we'll get x plus 1 to the square plus 0.
Yes, can you sign at the back of the paper, please? So when you factor, so you have r squared plus 2r plus 1 is r plus 1 squared, right? So r squared plus 2r plus 1 is r plus 1 squared, and this is equal to 0. And this is why we call it a double root, right? Because you have 2 times r plus 1 is equal to 0. So this is double root, right? This is double root because you have r plus 1 squared. All right? Now in this case, what is x1? Yes? E to, can you sign the back of the paper, please? E to the minus t, right? What is the second solution? Yes? Yes, can you sign the back of the paper, please? So the second solution is t times the first solution, and this is t e to the minus t. So what is the general solution? Yes?
Xt is c1 e to the negative t plus c2 t e to the negative t.
Can you say at the back of the paper, please? So xt will be e to the power minus t, c1 plus c2 t e to the power minus t, right? This is, so the last case is very simple. I explain again. So now, this is a second order differential equation, homogeneous second order differential equation with constant coefficient. All right? So you write out the characteristic equation. The one here will be projected to r squared, the two here will be projected to r, and the one here is projected to 1. Then you have the equation, r squared plus 2r plus 1 is 0. Now you compute the delta. The delta will be computed by taking the square of this one and taking that quantity, you subtract that quantity with 4 times the product of 1 and 1. You want to get 0. The delta is 0, meaning that you have a double solution. So the double root is minus 1. This can be seen because you can factorize r squared plus 2r plus 1 as r plus 1 squared. So r plus 1 squared is equal to 0, meaning that you have r plus 1 is equal to 0 twice, meaning that you have a double root minus 1. Then you use the formula. The first one is exponential of this double root, which is exponential minus t, and the second one is multiplying the first one with t. Basically, this is the solution, right? Questions? So this is how you solve first order homogeneous second order differential equation. Now we're going to try to learn how you can solve non-homogeneous second order differential equation with constant coefficient. Right, to solve the homogeneous second order differential equation with constant coefficient, you have to memorize the 3 cases and all of the formulas. Now let us try to do one thing, which is the non-homogeneous second order differential equation with constant coefficient. All right, so to know how to solve this equation, let us consider the following special case. So solve the equation, example. Solve the equation x prime plus x is 10 times e to the power minus 3t. All right. solution. Any ideas of how to solve this equation? Right, so let us consider the following solution, right? So consider xp to be e to the power minus 3t. What can I say about these functions? So I consider a function which is e to the power minus 3t. What can I say about this guy? Yes?
It's a solution.
Yes.
of
Can you say at the back of the paper, please? So this one is a solution of this equation, right? Why? Because when I consider x prime, I'm gonna get minus 3 e to power minus 3t, right? I take the first derivative, it gives me minus 3 e to power minus 3t, all right? I take the second derivative, this gives me minus 3 squared e to power minus 3t, and this is 9 e to power minus 3t. All right? It's clear? I take the first derivative. So the exponential derivative will give me an exponential, but the minus 3t derivative will give me minus 3. Now I take the second derivative. This gives me 9 times e to power minus 3t. Right? So what is the x second plus xp? X second plus xp, xp second plus xp will give me e to the power minus 3t plus e to the power minus 3t, and this is 10 e to the power minus 3t. All right? So xp is a solution. xp is a solution. And we call this a particular solution, right? Particular solution. Or special solution. Right? It's clear? So, I explain again. Now I pick up one function which is exponential of minus 3t. I plug it into the equation. So xp second will give me 9 times exponential minus 3t, and xp give me exponential minus 3t. Right? So you take a sum, you get 10 times exponential of minus 3t. So I said that this is a special solution, or a particular solution. So can you guess what is the next step? No? So now, a hint. So what can we say about x minus a? What can we say? X minus xp. So x is the solution of this non-homogeneous equation. xp is the particular solution, or the special solution that I just found. What can we say about the difference between the two? Yes?
Will it also be a solution because it's a linear combination of two solutions?
This is almost true. Can you say at the back of the paper? But this is not precisely what is going on. This is close to the answer. So what is what happened with x minus xp? Now let me write it down this way. So you have x prime plus x is 10 times e to the power of minus 3t. Right now I have xp second plus xp is equal to 10 e to the power minus 3t. I take a difference. What do I get? You get 0 only on one side.
Or you get x second prime minus the xp second.
So x is the solution of this guy. Yes?
We get x prime plus x equals xp double prime plus xp. Sorry, x double prime plus x equals xp double prime plus xp.
That means
Because it's 0 on one side and you're subtracting the two equations from each other, so they should equal each other.
and what is the conclusion?
Oh, x minus xp is 0. Or 1.
Is the P the like subscript or is P like a variable?
No, P is the subscript.
Okay,
P,
so that would mean that X is the coefficient.
no. So I call it xp, but this is just a name, right? Right. So let me call it y. Right. So this, let us consider this y, this function to be y. Right. So and then I have y second. So forget about the p. P means particular. Right. So xp is x particular. P is the particular. Right? So the p doesn't mean anything. So this is y. All right? Now, I consider y to be this guy, and y is the solution. Now, I take this difference, right? On the right hand side, this is 0. On the left hand side, you have what? You have x minus y second plus x minus y is equal to 0. So what can I say about x minus y?
X minus y is also going to be a solution
Of?
of the original differential equation.
No, the original differential equation has is non-homogeneous.
What we found is a homogeneous
Right.
equation, so we can use the characteristic
Right.
method to solve
Right. Can you sign the back of the paper, please? So x minus y is the solution of the homogeneous equation, right? So x minus y is the solution of the homogeneous equation. Homogeneous equation. Right? So, I mean, the magic is that, okay, suppose that I can find one solution. I subtract that to the equation, right? So when I subtract, can you sign the back of the paper, please? When I subtract the two things, the right hand side disappears. So x minus y second plus x minus y is equal to 0, which means that x minus y is the solution of the homogeneous equation. And then I can use the formula that I have before, right? It's clear? Right? So now let us try to solve x minus y. So now let us try to solve solving x minus y second plus x minus y is 0. So what is the characteristic equation for this equation? Yes?
A squared plus r equals
Yes, can you say this? So here you still have r squared plus 1 is going to be 0, right? Is it clear? I explain again. I have an equation which is inhomogeneous. Now I pick one function which is exponential minus 3t. Luckily, this is also a solution of the equation because when I compute y prime plus y, I get 10 to the exponential minus 3t, which means that y is a special solution of the equation, where y is one of the solution of the equation, right? So now if I subtract the solution of the equation with this particular solution of this special solution, I'm gonna get back the homogeneous equation, right? So which means that when I subtract x minus y is the solution of the homogeneous equation. So I go back to the homogeneous equation. To solve homogeneous equation, I know how to solve it because I have to write down the characteristic equation, which is r squared plus 1, right? So what are the two solutions of this this guy? Two roots. Yes?
R equals -1, right? Oh wait, no, that's r equals
I Can you say at the back of the paper, please? So then r squared is minus 1, meaning that r is plus or minus I. Right? It's clear? Now, let us. So, what are the two solutions of this homogeneous equation? Yes.
Would it be e to the I times t?
E to the it, yes. And what is e to the it? It's cosine sine. Can you say at the back of the paper, please? So we still use the same strategy. Before you have what? 0 plus or minus 1. The 0 will go to the exponential part, right? So you have exponential of 0t, cosinus of 1t, right? So the first solution will give you cosinus of t, and the second one is exponential of 0. So the 0 is going here, and the 1 is here. And the second one is sinus of t. So this gives you sinus of t. All right? It's good. So which means that x minus y has to be c1 of cosinus of t plus c2 of sinus of t. Right? So this is the formula that we learned. Meaning that x will be, because y plus c1 cosinus of t plus c2 sinus of t. Right? So which means that you have exponential of minus 3t plus c1 cosinus of t plus c2 sinus of t. I explain again. So when I subtract x minus y, x with y, x minus y satisfy the homogeneous equation, right? To solve the homogeneous equation, you use the table. In this case, you have the characteristic equation is r squared plus 1 is 0. You have two solutions, plus or minus I. You use, this is the case number 2, right? This is case 2. So this is case 2. So r squared plus 1 is 0, meaning that r is plus or minus I. So this is case 2. I'm going to use the table in case 2. So this is 0 plus or minus 1i. So the 0 will go to exponential. Plus and minus will go to sinus. So this gives me cosinus and sinus. So x minus y will be c1 cosinus t plus c2 cosinus t. Right? So which means that x will be y plus c1 cosinus sin, t plus c2 sinus t. And then this gives me exponential minus 3t plus c1 cosinus t plus c2 sinus t. Questions? It's good. I explain again. So the key here is the following. I want to solve this equation. X second plus x is 10 times exponential of minus 3t, right? Suppose that I can find a solution for this, one solution only, right? In this case, this is exponential minus 3t. So this y is exponential of minus 3t, right? So here I wrote it y, but basically this is exponential of minus 3t second plus exponential of minus 3t, right? So you want to solve x second plus x 10 times exponential of minus 3t. I found one function, exponential of minus 3t, and when I take a second derivative of this guy plus this guy, I get 10 times exponential of minus 3t, right? I subtract the 2. When I subtract the 2, I have x minus exponential of minus 3t plus x minus exponential of minus 3t, right, is equal to 0, right? Meaning that x minus exponential minus 3t is the solution of the homogeneous equation. So here I don't use the y or xp, but in general this is called xp. Right? So x minus exponential of minus 3t is the solution of the homogeneous equation. So to solve homogeneous equation, I have the table. Right? So I write out a characteristic equation, I write out the two solutions, right? And here, two solutions are complex, which means that we are in the second case. So in the second case, I have R0 plus or minus 1i. So the 0 will go to an exponential, and the 1 will go to the cosinus and sinus, right? So which means that x minus exponential of minus 3t is C1 cosinus t plus C2 sinus t, which means that x is exponential minus 3t plus C1 cosinus t plus C2 sinus of t. It's clear? Questions? Yes?
Could you explain how did you pick the e to the negative 3t?
This will go to the next lecture. How do you choose the particular solution? But in here, the concept is that if you can find one particular solution, then it's going to be the homogeneous equation, right? But in the next lecture, we're going to see that there are 9 cases that you can, there are 9 cases for the homogeneous, for the inhomogeneous case, and in each case, you have a different particular solution, right? It's good, questions? Right, so, all right, so to understand this better, let us try to solve another equation. Example, x second plus 2x prime plus x is 4 times e to the t. Right? Now, we have this equation and we want to solve it. Can anyone guess a solution for this equation?
E to the t.
Yes, can you say at the back of the paper, please? Particular solution. E to the t, right? So I call it xp. P means particular. Right? I call it xp. P means particular, but this is the name, right? Now, this is the particular solution. Why? Because when I take e to the t second plus 2e to the t prime plus e to the t, I'm gonna get e to the t plus 2e to the t plus e to the t. And this gives me 4 times e to the t. Alright? That's good. Now I'm gonna subtract this equation. Because x is 4 times e to the t, and now I have e t second plus 2e to the t prime plus 2e to the t is 4 times e to the t. Right? Now that I subtract, it's clear? I explain again. First, somehow I have a particular solution, and how to choose it will be the subject of the next lecture. We're going to have a lot of exercises on choosing this solution, right? But now let us try to understand. Yes?
Why is it plus 2e to the t? For that?
This one?
No.
And
The x right before the equal sign.
Where is it?
the last line that you
Okay,
wrote.
thank you. Okay, thank you. Can you sign the back of the paper, please? All right, so somehow you can choose, you can find one solution. Here, it is clear that this is exponential of t, because you take exponential of t, you take the second derivative, plus 2 times exponential of t prime plus exponential of t, you're going to get exponential of t plus 2 exponential of t plus exponential of t, and this gives you 4 exponential of t, right? Now I have two equations, right? I have x second plus 2x prime plus x is 4 times exponential of t, and this is e to the t second plus 2e to the t prime plus e to the t is 4 times e to the t. So what happened with the difference? If I subtract the two equations, what do I get? Yes?
X minus e to the t to the second derivative plus 2 times x minus e to the t to the first derivative plus x minus e to the t 0.
Right. Can you say at the back of the paper, please? So when I subtract the two equations, I have x minus e to the t second plus 2 times x minus e to the t prime plus x minus e to the t is 0. Right? Which means that x minus e to the t is the solution of the homogeneous equation. Hence, x minus e to the t is the solution of the homogeneous equation. Right? When you subtract the two, you get x minus e to the t second plus x 2 times x minus e to the t prime plus x minus e to the t, which means that x minus e to the t is the solution of the homogeneous equation, right? So what is the characteristic equation for this? Yes?
R squared plus 2r plus 1.
Yes, can you say in the back of the paper, please? So the characteristic equation will be r squared plus 2r plus 1 equal to 0, right? So, what is the solution for this? Yes?
R equals negative.
Yes, can you sign the back of the paper, please? So here, again, this is something that we have made. So you have a double root, which is r is equal to minus 1. Right? So, which means that, what is the form of the general solution for this equation? Yes?
Would it be would it be e to the negative t plus t e to the negative t?
Yes, can you sign the back of the paper, please? So the first solution is e to the minus t, which is e to rt. And the second one will be t times e to the power minus t. In this case, you have c1 plus c2, right? Which means that x minus e to the t has to be of this form, right? And which means that x has to be equal to e to the t plus c1 e to the power minus t plus c2 t e to the power minus t. It's clear? I explain again. The first thing that I do is I try to find one special solution for this equation. In this case, the special solution is c to the t. xp means that p is the particular, so xp is just a name. So when I subtract the two equations, x minus e to the t will be the solution of the homogeneous equation, right? So because x minus e to the t is the solution of the homogeneous equation, I can use the table. I write out the characteristic equation is r squared plus or plus 1. So for this equation, we have a double root, which is minus 1. So I use the formula. I have x minus e to the t will be c1 exponential minus t plus c2 t exponential minus t, right? So which means that x has to be e to the t plus this combination. It's clear? Of course, how you choose this, how you can find this special solution is a lot of game, and then we're gonna learn about that in the next lecture, because we have several cases for this, and it's complicated. All right, but the concept is the following. All right, so to solve the inhomogeneous equation, ax second plus bx prime plus cx is equal to f of t, right? So this is inhomogeneous equation, because on the right hand side it is not 0. So ft, in this case, is 4 times exponential of t, right? To solve the inhomogeneous equation, we